moles of N2O4. I'm going to put 2 moles of N2H4 on the bottom so that the units will cancel, and 1 mole of N2O4 on the top. Now I multiply across the top and divide by the bottom to get 1.36 moles of N2O4. The next one is the same process. Using the mole ratio from the same balanced equation, I put 2 moles N2H4 on the bottom and 3 moles N2 on the top. I multiply and divide to get 4.08 moles of N2. Mr. Mole says, that's not so hard, is it? The best advice I can give you as we work through this stoichiometry unit is to follow the method and let the units guide you. Now, we will move on to something a little more involved. Remember the problem the 2 students were trying to solve at the beginning of the program? Let's work through the problem, keeping this advice in mind.
Remember that you must work with a correctly balanced chemical equation in all stoichiometry problems. Start by writing the balanced chemical equation for this reaction on your note sheet. Check your work. Then write your problem in the famous question mark format.
This problem is a little different than the last couple because you are starting with mass instead of moles. The thing to remember is that the coefficients represent the mole ratio. So you must always have moles before you can make the switch. By that, I mean you start with information about one substance in the reaction, but you are asked for information about another substance in the reaction. To make the switch between these 2 substances, you will need to be working with moles, so that you will be able to use the mole ratio. Let me repeat it because this is important. The mole ratio is the step you must use to make the switch when you are given information about one substance in the reaction and asked for information about another substance in the reaction.
That's not a problem because you learned how to convert from grams to moles in the last unit using molar masses. So go ahead and put in the conversion fact to convert the 8.0 grams of hydrogen gas into moles. But don't multiply and divide yet because you're not finished. Don't forget that the question mark tells you what you are looking for. At this point, you will have moles of hydrogen gas, but you need moles of water. You just had to put grams on bottom and moles on top of your conversion fact. Now you just need to use the mole ratio to make the switch and convert from moles of hydrogen gas to moles of water. Now that you have what you're looking for, multiply and divide to get your final answer. 4 moles of water.
How do you like that? A problem that sounds so challenging is really quite simple if you follow the method. I want you to try a couple more before we call it a day. After you've had a chance to work them, I'll be back to go over them with you. Your local teacher will put the following problems on the board for you, so you don't have to try to copy them now. Remember photosynthesis from biology? As a refresher, carbon dioxide and water react to form glucose, C6H12O6, and oxygen gas. If 15.6 grams of carbon dioxide react, how many moles of glucose will be produced? How many grams of carbon dioxide must react to produce 0.25 moles of glucose?
Local teachers, please pause the tape.
The first thing you needed to do was write a balanced equation. You should be a pro at that by now, so I'm sure you balanced it correctly. Next, you set up the first problem in the question mark format. How many moles of glucose equal 15.6 grams CO2? Of course, you let the units guide you through the problem. The first step is to use a conversion factor to convert grams of CO2 to moles of CO2. Put 44.0 grams CO2 on the bottom and 1 mole CO2 on the top. Now that we have moles, we are ready to make the switch. So the next conversion factor is the mole ratio from the balanced equation, our key for making the switch. We put 6 moles CO2 on the bottom and 1 mole glucose on the top. Since moles of glucose is what we're looking for, we are ready to multiply and divide, and we get 0.059 moles of glucose. That wasn't so hard. Now, let's work our other problem. How many grams of CO2 equal 0.25 moles of glucose? Since the problem gives you moles, you are ready to make the switch right from the beginning. Using the mole ratio, you put 1 mole of glucose on the bottom and 6 moles CO2 on the top. Letting the units guide you, you next put 1 mole CO2 on the bottom and 44.0 grams CO2 on the top. Since grams of CO2 is what we're looking for, you multiply, then divide, and get 66 grams CO2. You'd better put your math hats on for a few minutes while you take the chemistry quiz.
Cumulative review question number 1. The periodic table tells you how many grams are in a mole of atoms of any element. This is known as the A. gram mole, B. molar mass, C. atomic mass unit.
Cumulative review number 2. When balancing a chemical equation, one is allowed to adjust the A. formulas of the reactants, B. formulas of the products, C. coefficients, D. both A and B.
And now for number 1. Stoichiometry is the study of what kind of relationship in a chemical reaction. A. Quality, B. Quantity, C. Reactants, D. Products.
Number 2 involves looking at a balanced equation. How many moles of hydrogen gas react with 1 mole of oxygen gas? A. 1 mole H2. B. 2 moles H2. C. 3 moles H2. D. 4 moles H2.
Number 3. What do the coefficients in a balanced chemical equation always represent? A. Gram ratio. B. Mole ratio. C. Both A and B are correct.
Look at the balanced equation for the formation of water again. Number 4. How many moles of water will be produced if 8.3 moles of oxygen gas react? A. 8.3 moles H2O. B. 16.6 moles H2O. C. 4.15 moles H2O. To solve number 5, you will need the same balanced equation. You will also need to know that the molar mass of water is 18 grams per mole. How many grams of water will be produced if 8.3 moles of oxygen gas react? A. 298.8 grams H2O. B. 74.7 grams H2O. C. 0.92 grams H2O. D. 0.23 grams H2O. We hope you did well with that, but you will do lots of practice before we meet again. You will need to build on what you learned today as we work through this unit. Don't make the fatal mistake many students do when they try to memorize what to do in each type of problem. Heed Mr. Mole's advice. Follow the method and let the units guide you. Mr. Mole and I will see you soon.